This is section 11.5, probability with the fundamental counting principle, permutations, and combinations. There's really not much new in this section, not really anything at all. We are going to be doing the same kinds of probabilities we did in the last section. The only difference is that now we are going to have to use what we learned about combinations and permutations earlier in order to get all the information. So this section is just about combining the information we already know. So let's look at an example problem. There are 3 men and 3 women in a line at a checkout counter. And how many different ways can they line up? So there are 3 men, 3 women, so there are 6 people total. We're asked how many different ways can they line up, so that means order does matter. So this is going to be a permutation. And there are 6 factorial ways of lining up. 6 choices in the first spot, then 5 choices, then 4 choices, and so on. So this is 6 times 5 times 4 down to 1, or enter it in your calculator, and you get 720. So there are 720 possible ways for this to line up, for them to line up. Okay, so in how many ways can they line up if the first person in line is a woman and then alternates by gender? So it goes woman, man, and so on. So let's just think about our 6 spots. We are told that the first person is a woman and that they need to alternate. So okay, it would look like this. And now for this first woman, we have 4 choices. Not 4, 3, sorry. For this man, we have 3 choices. For this woman, out of the 3, we've already placed 1, so now there are 2. And then there are 2 men left, and then 1 and 1. So basically, we have 3 factorial times 3 factorial, or just 3 times 2, just multiply it straight out. And so 3 times 3 times 2 times 2 times 1 is 1 is 36. So this is how many different ways they can line up in general. This is how many ways they can line up with this specific requirement. Okay, now let's find the probability that the first person in line is a woman and that the line alternates by gender. So we're talking about theoretical probability here. It's the number of ways, a number of outcomes in event E. So how many different ways can we meet this requirement? 36. And that's 36 over the number of possible outcomes, the total number. So that would be the number of ways they can line up just in general. And we found out there are 720 ways for them to line up. So the probability of that event, which is that they're lined up in this particular order, is 36 over 720, which reduces down to 1 over 20. So the probability of them lining up exactly that way is 1/20. Okay. So there are 7 performers, A, B, C, D, E, F, and G, and they are supposed to appear in a fundraiser. The order of performance is determined by random selection. And find the probability that D will perform first. Okay, well, first of all, we have to figure out how many different ways they can line up, period. Okay, so I have 1, 2, 3, 7 performers. So there are 7 factorial ways to line up in general, which if you punch that into your calculator, you get 5,040. So there are 5,040 ways for them to line up, period. Okay? So how many ways can we do it if D performs first? Well, if I place D here and then I have 7 spots, I have seven spots in general, so that's good. I got them right. So D is first, and now it's just how many different ways can we place these? So basically, we have 6 spots that we need to fill with the rest of these. We've taken D out of contention. So right here, how many different ways are there to do this? Well, this would be 6 factorial. which is 720. Okay, so what is the probability that D is first? Well, there are 720 ways for that to happen. And there are 5,040 ways to line them up in general. And then this fraction reduces down to 1/7. Okay. So this is basically the same kind of idea, but what is the probability that E will perform sixth and B will perform last? So we have 7 spots. We say E will perform sixth and B will perform last. So now we have to basically, we're worried about the order of these 5 because these 2 have already been set. So this will be 5 factorial right here. Okay, 5 factorial is 120. So the probability that E is sixth and B is last, not blast, this would be 120 out of the 5,040, which will reduce to 1/42. Okay. Now, what is the probability that they perform in exactly this order? Well, there's really only one way they can do that, right? I mean, the order is given to us. There's no choices, no way to rearrange anything. So the number of ways this can happen is 1. So it's one way out of the 5,040 possible ways to line up. 5,040. That's the only way this can happen. So the probability of that is 1/5040. Okay. What is the probability that F or G will perform first? Okay. So we have 7 spots. And I know this one is F or G. And then the rest of it doesn't matter. Okay. So for this spot, we have 2 choices. Now for the rest of these, it doesn't matter. So if this is F, it doesn't matter where G is. It's just somewhere over here. There's nothing else given. So same thing if G is here, then F can be anywhere here. So really for here, I'm looking for how many different ways I can order these. And since there are 6 spots, that's 6 factorial. So how many different ways can we do this? It's going to be 2 times 6 factorial, which is 1440. So the probability that F or G is first would be 1440 over 5040. And then if you reduce that, it reduces down to 2/7.